Good morning, everyone. I'm just making sure that I have everything set up correctly, and it looks like I do. So let's get started. Welcome to another installment of MBF Bioscience's TJIF webinar series, or TJ's Information Friday. I've taken a couple of weeks off from providing these webinars to work on getting some of our product updates out the window, or out the door rather, but I'm happy to be back and presenting these for you guys once more. For the return of this installment, I wanted to provide an opportunity to kind of open the floor up to everyone who's attending. And today we'll focus on questions that you might have relating to our quantitative analysis program, Neurolucida Explorer. Although this program has the Neurolucida name to it, that does not mean that it is strictly compatible with data that is coming from either Neurolucida Desktop Edition, Microscope Edition, or from Neurolucida 360. For individuals who may be working with our other programs, such as Stereo Investigator, NeuroInfo, Tissue Mapper, and many more, there are analyses in Neurolucida Explorer that can help answer questions that would go otherwise unaddressed. Just like the other TJIF webinars, and probably more so, the overall success of today's webinar is in part due to the questions that you all come up with. And because this is a question and answer session, I thought it would be important to quickly cover how you can submit questions. So when you develop a question during this webinar, please feel free to send them to me. No matter what point during the webinar the question pops into your head, send it on over and I'll be happy to do my best to answer that during our allotted time. Submitting a question is as easy as finding the orange arrow on the GoToWebinar panel, extending the panel outward, finding the question section, and then typing in your question below and hitting send. If there are topics that you'd like to see covered or questions relating to your research specifically, please don't hesitate to ask. That's why we're all here. Lastly, this webinar is being recorded and will be available to view later, and a link will be sent to the email that you had provided. So I think we can go ahead and get started. And the first thing that I want to do is just jump in and show the Neurolucida Explorer page at its default. This is what you'll see when you open it up. And to start, I had a couple of questions that I wanted to give to you guys that usually come in from the free trial process and for new users. So one of the big things that we'll typically see is as people start to generate massive data sets, there tends to be a lot of markers that get generated. So markers are a really great tool to either put something, to mark something of importance, or to just get a good understanding of location of things, or if you need to mark cells. But regardless, once you have markers placed down, you can see that as the data file shows up at its default, they can be a little bit difficult to visualize right away. So one thing that we can do is go to the File and Preference menu, and we can actually look at the markers themselves, and we can see that we can generate the size in microns, in pixels, or intrinsically. Typically when it's set to intrinsic, that's when there would be a difficult time spotting those markers. So if we just increase the marker size, let's say to about 1.3, just giving it a little bit extra size behind it, we can see that they're a lot more easily visible, and they're actually going to be a little easier to click as well, because markers are different than all the other objects that get presented in Neurolucida Explorer. When we click on a contour, it'll highlight in a nice bright white color for us so that we can easily distinguish what we're seeing from the background or from the other data that we're looking at. Markers, on the other hand, are a little bit more difficult, because when we do select an individual marker, I'll zoom in on this one specifically, it's very important that we click the very center of that marker, or else we won't see a nice kind of shadow behind it, which shows us as the user that we do have one item selected, and that would be this individual marker. If you find that as you're clicking through your data file, you're having a tough time getting those markers selected, we can also return back to the File and Preference menu, go to View, and we can increase the selection distance tolerance. Essentially what we're doing there is we're allowing for a percentage of the screen to be the clickable region, and in that sense, when something is within that clickable region, that would be the object that gets selected. Another very easy way to select markers is to open up this Trace Structures tab, which is in the View kind of tab, and it's just going to open up and provide us with everything that's been generated for this data set. So specifically, if I want to look at all of the markers that have been generated, I can highlight the markers field, and I can click on these blue contours by holding down the Control key, and in just a second, I'll zoom out, and we can see that not only do we have all the markers selected, we have these open delineations selected below as well. A really powerful analysis that we'd like to show off is under Analyze and Markers in Region. When you have these open delineations, it'll allow us to do the marker to surface distance analysis. And this is one that is another extremely powerful tool that will, help answer questions that you may have. But the important thing here is that when we do this, we're going to create a surface with these open delineations. And if I just move this data table over slightly, we can see that we've now generated a flat surface for these delineations. And in this sense, when we go through, we're looking at the closest distance to the surface at any point with these markers. So this is a fantastic way of being able to get a nice distance measurement from anything like a region of interest that you're looking at to an anatomical structure. Anything that you would like to find that significant distance to, we can do that right here within this initial analysis. Another question that gets asked pretty frequently is, after you've done an analysis and you return to try and do a second one, things can be grayed out. You'll notice again, we don't have anything that we're really able to run an analysis on, and that's just a simple question of, is anything selected? When you load a data file into the program to start, it will have every object selected and enabled for analysis. But once you've run an analysis and clicked into the 3D space in any capacity, it's going to remove that selection for you. So simply select what you'd like to run the analysis on again, and then you'll notice that things start to become more populated with results that you can, or with reports that you can start getting results from. It looks like we have a couple of questions that have come in, so I'm going to just hop back into one quick question again that we see on the kind of demonstration and free trial side, and then I'll be happy to answer these questions that we see. So I'm going to bring in a different data file, and there's a lot of different ways that we can do that, but because I've worked on this one recently, I'm going to go to Recent, and I'll select this. It's a very simple Neuron. If you've joined us for a lot of these webinars, this might have been something that you've seen before. But very simply put, if I select everything in this Trace Structures tab, and I go to Structure and Branch Structure Analysis, one of the questions that we get asked quite frequently is, what are the differences between some of these analyses? A lot of them seem like they're doing the same thing, but when I get to the report, it's not the same data. And that's true. Although we have each tree an individual tree, they sound like they're doing the same thing, but one important factor is what's being reported on. If you look at this screenshot or this picture that's generated in the center of the kind of data table or analysis selection window, we can see exactly what's going to be reported on. So when we look at each tree, we're not looking at the total segment, we're looking at individual segments that comprise the larger tree. So anytime we hit any sort of branching space, we're going to consider that a new tree rather than reporting on it in its whole. In the reverse, when we go to individual tree, that's going to be looking at the tree as a whole rather than the segments that generate the tree. So when you're doing analyses, it's going to be very helpful to look at these pictures that we're providing to help guide you toward what you might be looking for. Another helpful kind of indicator is that we do have part of the results at the top underneath the name of the individual analysis. So we'll be able to see that each tree will look at the segments, the spines, and some smaller components, whereas individual tree is going to look at the length of the segments in its whole, in its entirety. So one question that came in from Paris or Perry, I apologize for the pronunciation, but the question is, our lab is trying to overlap a bright field image in order to measure the soma size of neurons, but we cannot work out how to change the transparency of images. Can we demonstrate that? Of course. So this is that's going to be more on Neurolucida 360. When you have those images open, let me close this and I will open up Neurolucida 360 for us. But when you have those images open, what we're going to do is we're going to look at the either image organizer is probably going to be, that's going to be the solution. So give me one quick second while I open that up, and then we can look at that together. Just as a follow-up question back, is this something that is being worked on between multiple images in one image? That would be helpful to know on my end, so I don't answer the question incorrectly. But here we go. So we have Neurolucida 360 open here, and we have our 3D environment. To start, I'm just going to close the 3D environment, and I'm going to go to the Image tab, and I'm going to select the Organizer, and I'm going to select the Adjust button. These are two tools that I find extremely helpful when working with any sort of data set. But more specifically, this is probably going to be the two areas that we'll look to kind of resolve the transparency question. Okay, so this is across multiple images. That's fantastic. Okay, so let me find the data set. Essentially, here we go, crop 1 and crop 2. So I'm just going to drag these image stacks into the program, and it will recognize that they are two separate stacks, and I'm going to load them in the grid layout formation. This is going to keep them as two separate images, and here we can see that we have the first kind of crop of the image and the second kind of crop as well. So here's what we're going to look at first. We want to make sure we have the right image selected. So when we do this, one quick and easy way to tell is if we use this eyeball icon to open, or not to open and close, but to show and hide the image data that we're looking at. Excuse me. So as we show and hide, we can see which image we're looking at. And in that case, what we can do is we can select with this checkbox which one we'd like to work with. The checkbox is going to be right next to that eyeball icon. After that, I'm going to go over to back to the image tab in that 2D window, and I'm going to select the montage tool. This is going to allow us to navigate and to kind of expand on what we're working with. And automatically when we do this, I'll close the organizer or the image adjustment tool for now, so we can create some more space for ourselves. But what we're doing here is we're really allowing the image data to be lined up properly. So as I zoom in, we can see, let me zoom out and actually get to the location we're looking for. So as I click and drag, you'll notice that the transparency slider, once we're in the montage mode, has been lowered automatically for the image that we're working with. As we lower the kind of trace opaque or the transparency slider a little bit more, it's going to be easier to find what we're working with. And then it's as simple as lining up the two images until we can show and hide and see that the image that we're working on is actually truly lined up with what we're kind of working with. At that point, what we can do is we can use this automatically align in X and Y to hopefully try and get a more precise alignment. If that kind of throws things off, we can always go back and utilize just the manual lineup that we've been doing so far. And if it's a Z stack rather than two 2D images, we can use this min or max projection kind of toggle or button for the Z alignment, and then we'll be able to automatically align in X, Y, and Z to try and get that corrected for you. And then lastly, the thing that you'll want to do is you'll go to File, Save As, and then Montage. That's going to allow the two individual stacks to be saved as one. So then you'll be working with, whether you want to compress it or not, you'll be working with a JPX image stack. And then from there, it won't open it directly in this image organizer. So my recommendation is to check off both images. You can close them using the little trash bin in the image organizer, or you can use the new tracing button in the top left corner to remove the two images that are opened, and then you can open up that image stack that you've just generated from the montage mode, which is that would probably be the best way to do that. Rather than sitting here and showing you guys a loading screen, I'm just gonna keep moving. But Paris, I hope that answered your question. Is there any way of improving spine detection in Neurolucida 360, such as increasing the contrast so that the spines appear more clear in the 3D environment, thus easier to detect? That is another fantastic question. So let me think about that for a second. So increasing or improving spine detection is dependent on the image data itself. We can get to a point where working with the image histogram a little bit too much can kind of kind of muddy things up a little bit. So if I bring in just a very simple image stack, this is the spine image stack that I'm sure many of you are very used to seeing at this point. I'll open up the 3D environment, and this is also this is made in an ideal environment. Not all images look like this, and that is very understandable. So in a second, if we want to, I can continue on with a different image stack. But to increase the detection accuracy, there's two ways to do that. The first would be to just simply increase the sensitivity. So right now I'm just tracing the tree. The two important things here, prior to doing any detections, we want to make sure that the image stack is acquired with a high-powered objective and with a z-step of 0.3 microns or less. That's going to enable us, if I close this and look at the 2D window really quickly, it's going to allow us to view individual spines while they're in focus for a little bit longer, which in turn will allow us to have the most accurate representation when we get to the 3D environment. So the second part of that is making sure that we have as accurate of a tree creation as possible when we start doing these spine detections. The more accurate the tree kind of definition and diameter, the more accurate our spine detection will be. And that is strictly because our spines are based out of our trees. The entire structure comes from the root of the spine, and that's how that connects to the branch. So in areas like this where we have a nice connection to the branch, using the detector sensitivity at its default might be perfect. But when we get over to things that are a little bit more punctate and staining, and we don't have as great of a contrast or a saturation, we might get floating spines like this, or we might get a result saying that we can't detect there. So a long-winded answer here is to improve the spine detection accuracy, there's two ways to do it. The first is to simply increase the sensitivity past 100. Very counterintuitive, but this doesn't decrease the accuracy of the detection. All we're doing is we're allowing for some of the more faintly stained pixels to be pushed through and to be accepted, if you will. By increasing the sensitivity, what we're doing is we're allowing the more dimly stained pixels to be detected, and thus we're going to allow for a more robust detection and calculation of these spines. if you get to a point where you're raising the detector sensitivity past 180 to 200%, there's always the option to work with the image histogram as well. Working with the image histogram, if I just hide the tracing that we've done here, by moving, depending on the staining, if you're working with a Golgi stain, you're going to want to work with this black point probably a little bit more. If you're working with a fluorescent image, you're probably going to want to work with this white point a little bit more. But essentially what we would do is by dragging in the edges of the histogram by the black point or the white point, we're going to increase the saturation that we're seeing in these stains. So in areas like this where we had our first spine that was detected, we can really see the difference in how saturated the head of the spine is, but more so how much more saturated the body of the spine is. As we start to move over a little bit further to the left with these two kind of purple spines that were detected, we can see that compared to the original, it's about double the saturation. So those are the two best ways to go through and detect spines. But really, the increasing of accuracy and detection, the first part is making sure that we have as accurate of a branch as we can. Then the next would be to work with what you have at the settings without adjusting that image histogram. And then the very last thing would be, if you have those settings and they're still not working and you can still visibly see that spine, it would be to work with the image histogram to really push out the saturation, and then to work again once more with these detection settings. So I apologize for making that kind of scrunched up face. I was just reading another question. If we have input the incorrect X and Y resolution for a Z stack, because the default is set to 1 rather than the actual pixel definition, so that the tracing shows a flat, can we change the X and Y resolution post hoc to recover the Z dimension? Fantastic question. So this is another thing that comes up, excuse me. This is another thing that comes up, especially with the scaling. So if I were to load, I'll load in probably a very similar image, but first I'm going to go to File and Preferences, Display, or maybe it is Tracing. I believe it's Tracing. Images, sorry. So what I'm doing here is I am just turning on the scaling dialog, so that way when I close and reopen the program, we will have the scaling dialog show up no matter what. Most of the images that we use so far, or all of them so far, have had the image scaling embedded within them. But that tends to not be the case when we use converters like Fiji or some other freeware that's out there. This is also a fantastic opportunity to plug Microfile Plus, the MBF Bioscience converter. It works fantastic, especially with large image data sets, whether you're working with multi-channel data to compile into an image stack, or whether you're working with a simple stack-to-stack conversion. There's a fantastic solution there, and I believe that's available for our customers on our website. If it's not, please feel free to contact our technical support staff or our sales staff. They'll be more than willing to help you. But just a nice plug to say that we do have a way to convert, whether it's to JPX or an OME TIFF, we can do that, and we can embed the scaling in right away. So hopefully you don't have to deal with multiple scaling windows when you're working with your data set, or in this case, as Alexis pointed out, potentially just putting in the wrong scaling because something was overlooked. And that happens quite frequently. So let me open up the image stack that I just had. Actually, I'll just open this one. It's a little bit different, but this is from the data file that I had shown earlier in Neurolucida Explorer. So Alexis, right here is where we're seeing, if the scaling was not embedded or the metadata was not present for the program to read, this is where we would see a 1 micron value for each input. Obviously, that is not correct for 99.9% of the image stacks that come in. So essentially the question was, if you open something with a value that is inappropriate, like 1 and 1, is there a way to recover it without having to essentially start over? Because as it was said, it creates a kind of smushed and flat image stack, and that can lead to an inaccuracy. To resolve this, we do have a tool to do that. And if you go to the Trace tab in the 2D window, so I'm just going to quickly rotate and show that we do have a little bit of an issue here where our image stack is flat. We know that that's incorrect. So I'm going to close this 3D environment. I'm going to go to the Trace tab in 2D, and then I'm going to go to Tools and Adjust XY Scaling. When we do this, we can put in the correct scaling. I believe it was something like 0.23. We can dynamically update and also adjust images. When I click OK, that should change the values that we've seen here. And then now, as I open the 3D environment, we should see a much more accurate representation. If you've generated data for this already, I believe going to this Tools section and adjusting the XY scaling, that should work with the data as well, as long as both of those checkboxes are covered, the dynamically update and also adjust images. That should do the trick. If that is not the case, feel free to reach out to our tech support team, and they may have a different solution that I might not be thinking of right at this moment. But that was a fantastic question, and that also does come up a lot. So thank you for asking that. One more question, not one more question totally, just another individual's question. I'm having trouble tracing very thick trees with the user guided option. Do you know how to resolve this issue? Fantastic question. So once again, I don't have the perfect data to explain this, but hopefully the combination will, the visual and audio combination will help. The user-guided mode is a fantastic way to trace. That's usually my go-to way because you do have the oversight. Let me actually close this down and open up an image with the proper scaling. Okay, so the user-guided mode is a great tool for tracing because it gives you, as the user, the kind of ability to follow what the program is suggesting, but you can also override it. So if you're getting to a section that has really thick processes, it depends on what method you're using. So because the different methods work differently, the way that the algorithm will target the diameter and calculate the diameter is going to vary. And depending on what type of image stain you're using, the kind of accuracy and oversight that you need as the user can vary as well. When you're working, in my experience, when you're working with thicker processes, I've found that the voxel scooping method tends to do the best. The Rayburst crawl also does a fantastic job, but the directional kernels tends to not get the full diameter typically because of any sort of breaks in the staining. It might kind of half get the diameter. So if you're not working with Golgi or any sort of bright field image, I would highly suggest working with the voxel scooping method. As you begin to trace, you should see the circular kind of seeds that are being placed. You should see them changing their diameters as well. If you get to a point where it doesn't look like the algorithm is targeting correctly, one quick and easy way to override what the user guided mode is suggesting is if you hold down the control key, it essentially puts you in the smart manual mode. And then from there, you can change the circular cursor diameter and adjust as necessary. You also have the opportunity, without doing the control kind of button press, you can switch to the smart manual mode on your own and use that control key and the circular cursor to really expand the the diameter of the tree that you're tracing. And then as you continue to click, you can work in the smart manual mode, and then you can return to the user guided mode as you please. All three modes, they work differently, but you don't need to work consistently in one mode throughout your entire data collection kind of process. You can jump between the different modes. You can start with the automatic mode and then work your way down until you get to that smart manual mode where you have complete control. Especially when you get to areas where the diameter is really varying and you get these thicker processes. The smart manual mode might be the easiest way to just kind of override any of the algorithm's suggestions, and you get to generate the data with as accurate of a measurement as you can. So hopefully that's an easy solution for you. Please let me know if that if that ends up working well. I'm curious to hear. This is probably going to be the last question for right now, but before I answer it, I'm just going to do one more quick plug, and that is for thank you for joining. Wonderful. But we do have a forums page. So if you did have a question that you didn't have the opportunity to ask during this webinar, our forum page is up and running. We have a lot of different posts on there, and we as like MBF Bioscience, we look through that pretty frequently. That's the word. And we're answering questions as they come up, kind of on the fly. And it also provides an opportunity for other researchers to see if the question that they might have is being asked and or answered. So before I answer this last question, I just wanted to say thank you for joining. And I will return back. The last question is for Z-stacks that have a greater Z-step than 0.3, is there a way to extrapolate or recover the missing spines? So I would say it's not necessarily missing. Let me pull that back. There could be spines that are missing. If the Z-step is larger than 0.3 and there's only a single image data plane that's showing the spine, it might be just overlooked. There's no real way to recover a spine that we don't have data for. Neurolucida 360 is looking at the pixels that are present. So if you do have a spine that is a bit overlooked, there's not necessarily a way to recover. The only way would be to re-image potentially with a smaller Z-step. With that being said, if you do have a Z-step that's larger than 0.3 and it's only slightly larger, essentially what we've seen, or what I've seen, is it creates a blur in the Z axis because of the spacing between the images that generate that stack. So when you have a Z-step that's larger than 0.3, it's going to create a little bit of a blur, which means that the spines are going to be elongated after they're detected. It creates a little bit of an inaccuracy, but you can still detect them. As long as the pixels are there, you should be able to get a detection. It just becomes more so the question of whether the data that's being produced is 100% accurate to the spine itself in the natural setting versus what we're seeing in the kind of snapshot experience that we're seeing with an image stack. Hopefully that answers the question. I apologize if that was a little bit long-winded and not an exact answer. But if you do have other questions, please feel free to post them on the forum and to try and get the answer that you're looking for. I do appreciate everybody's time today once again, and I do appreciate the questions that y'all had asked. As always, thank you for watching and joining, and I look forward to the next webinar that I have an opportunity to spend time with you guys. So thank you again, and have a wonderful weekend. Take care, everyone.